Did you guys hear that? All right, what am I doing? Morning. Good morning. How's everybody? So there are some really good questions during office hours. Let's see. Anybody else have questions from homework or anything?
Yeah, I just had a quick one on homework 2A. Number 14 on the multiplying fractions. I think I'm just doing my math a little bit wrong as far as like the steps I'm taking, because like so the problem is, are you looking at the problem?
Yeah, I got it coming. I gotta flip through these pages. All right, here.
Okay.
Oh wait, 2A you said, right?
Yeah.
All right, let me go back this way. Okay, there we go. Now I'm 14. Yeah. So I'm glad you're asking this question. A lot of people got this wrong. Which one?
Number 14B, just the multiplication ones, really.
All right. So this is beautiful. I'm so happy you're asking this because I meant to talk about this before. At that point, I only graded a few of these, but now I've graded more, and I'm seeing a lot of the same issues. So now watch. This is really, really, really cool.
You know, the paper that you gave us, that handout, was really helpful.
Cool. That is always my hope. Let me see. Stay with me for a minute. This is going to sound completely not relevant, but just stay with me. What is x plus x?
2x.
2x. All right, this might be a little freaky, but can you do this? No, let me just stop everybody. Cannot add those together. Those are not like terms. I've got 1x and I got 1x squared. I don't have two anythings, right? But could I do this? Yes, because now I got 1x squared, another x squared, I got a couple of x squared. Is everybody with me? That's the basics of like terms. And then whoever asked the question is like, okay, thanks, man. That has nothing to do. Now, yes, it does. Hold on. Can you do x times x squared? Hell yeah. Does anyone know what x times x squared is?
X cubed?
Yes. Because all an exponent means is how many x's do I have multiplying? Well, I have 2 and another one, so I got 3 of them. Ooh, so can I add these things? No. Can I multiply these things? Shit, yes. So addition, subtraction requires exact like terms. Multiplication and division doesn't require exact. It's a lot less restrictive. So what does that have to do with fractions? Okay. So can I add 1/5 and 3/10?
No.
Hell no. Why? Because I got 1 of these plus 3 of those. But I can make them like terms, right? So I can multiply by 2, 2/10 plus 3/10 is 5/10, which is 1/2, blah, blah, blah. Right? Is everybody cool? You're like, sure, man, we're all really cool. All right. Do I have to do this if it's 1/5 times 3/10? No, I don't need like denominators. When you multiply or divide, you do not need like denominators. You don't need like terms. Just like you can't add these, but you can multiply them. So how do I multiply this? Well, does anything cancel? No. So I get 3 over 50. Is that good? And we're going to take one more step with this. Do you guys see that? So way too many people would get this problem and make like denominators, but that doesn't make sense because when you're dividing, multiplying, you want to try to reduce things, not build things up, right? So now watch this. There is a beautiful thing you can do. You ready? Look at this disgusting thing I'm doing here. 42 over 49 times, what do you got, Jeff? I don't know, Jeff. Let's not do that. 42 over, what do you got, dude? Yeah, sure. 55 times 44 over 21. Look at that. Do you want to do 42 times 44 and 55 times 21? You get that answer? No. And you're all like, I don't want to do any of it, but you have to, so too bad. What can you do instead? Can't you reduce? Can't you reduce right there?
By 2.
No.
By 21.
I think you're thinking what's going to be left here. You can divide by 21, right? And then what can you divide by here? What can reduce here?
11.
11. So then you would get 8 over 5. Now, of course, the problem you asked me about is a lot easier, right? Now, real quick, I really want to show you, just in case. Let me do this problem again. Let me really, really put it in your face what the shit's going on. This is 2 times 21. Let me do it like this. 42 is 2 times 21. 55 is 5 times 11. 44 is 4 times 11. 21 is 1 times 21. The 21 is on top and on the bottom. The 11 is on the top and on the bottom. 2 times 4, 2 times 4, 5 times 1, 5 times 1, right? Is that?
So you factor it.
I'm sorry?
So you factor it?
Factor it, exactly. Because when you're multiplying and dividing, common factors get killed. So I get way too many people giving me a problem like if I give you 3/5 times 5/4, I'm getting people do this. They make them like denominators. You could do it, Jeff. There you go, buddy. And then they multiply the top, and somehow the 20 times 20 is 20. Now that is really magic. Right. I'm not trying to make you feel bad if you did this, but I want you to notice that is what you're saying. 20 times 20 is 20. That's some shit. Now, if you do this, you will eventually get the right answer, but my God, you went a far way to get there, right? That's all you had to do. The 5s kill each other, 3 over 4. And that's where you're going to end up finally here. You're going to finally get to 3 over 4, but wow, it took a long time to get there. So multiplication, sorry, go ahead.
So multiplying and dividing, you break them down, adding and subtracting, you build the bottom up.
You build them up so they have the same bottom, because adding, subtracting requires exact like terms. Multiplying, dividing doesn't. You don't need LCD for multiplying and dividing because, like you just said, the whole point is to try to kill things. Okay, maybe. Then I get people that will do this kind of thing. What do you got, Jeff? I don't know, Jeff. And then, I don't know, some weird shit happens. What did I already do wrong? Can anyone see what I've done wrong? Or does that look okay to everybody?
You shouldn't have canceled those out already.
Why not? Why can't I cancel them? Isn't that 5 up there and the 5 down there?
You need to have like terms on the bottom to be able to do anything.
No. I agree with what you said, but it doesn't really address what I've done wrong. So is it okay to kill the 5s on this problem? Can I kill the 5s? Yes. Why? Because what's this operation? Multiplication, right? And this is division. Those cancel. What's happening here? Division and subtraction. Do those kill each other? No, don't do that. Do you guys follow? So just because one's on the top, one's on the bottom, doesn't mean it cancels. The operations have to be opposite. Let that make sense. What's the only way two things can cancel is if they are doing two opposite things. And these aren't. This is dividing 5 and this is subtracting. That's not opposite things. Dividing, multiplying. Yay, die 5. Okay. Is that all right? Do you guys?
Hey, Professor, I had a question really quick.
Sure.
When I was doing the 2A homework, I got a couple of questions or answers that were improper fractions. Did you want my final answer to stay an improper fraction, or should we turn it into a mixed number?
If the problem doesn't say, it doesn't matter.
Okay.
If it was like a word problem, if somebody said, how far away do you live? And you calculated and you said, I live about 77/13 miles. They're going to look at you like, what, who the shit? Right? So it depends on the situation. If they don't say, it doesn't matter. If it's a word problem, you should probably take this at least into a mixed number, right? All right. But if they don't say, it doesn't matter. You could do improper or mixed. I like it.
Are you
Real quick
able
thing
to
about-
go- Okay.
Sorry, go ahead.
Well, if you're still answering questions, 13 on 2B, all of them.
Oh shit, where did I put this? 13 on 2B. All right, 2B is page 10 something. All right, here we go. 13. Okay, good. Perfect. Here's the other thing. I love it. Kick ass. Here we go. Most of you guys did okay with a few of those. And then the minute they brought negative exponents in, it went to shit, which is understandable. Because we might not remember what negative powers mean. So real quick, I know they have tens here, but it doesn't matter what the base is, really, as long as it's the same. What's this, for example?
X to the 9th.
X to the 9th, because when I have like bases multiplying, I add the powers. Why does that make sense? Because there's 2 x's times 7 x's. So, of course, there's 9 x's in a chain. Okay, I like it. Now, what's this?
X over 5.
Say it again.
X over 5. I don't know if that's a 7 and a 2.
It is, but it's not x over 5. It's x to the, right?
Or X to the 5th. I'm sorry.
Yeah, and don't do what I'm doing right now, but here's the reason. 2 x's cancel, and you're left with 5. So what's the shortcut? 7 minus 2. So when you multiply, you add powers. When you divide like bases, you subtract powers. Now, what does x to the 0 mean?
1.
Yes. Does everybody? Well, I already gave you the answer, but why is this true? Well, no, stay with me. If I had x squared divided by x squared, what's the rule? Subtract, right? What's 2 minus 2? 0. But what the shit is something divided by itself? Something divided by itself is 1. Bam. So anything to the 0 power is 1. Okay, maybe. Now we're ready. Here's the ultimate question. What the hell does a negative power mean? So to investigate this, I could do something very similar. 2 minus 3 is negative 1, correct? But another way to look at this is if I have 2 x's over 3 x's, how many x's cancel? Right? Isn't that x squared and x cubed? How many x's cancel?
4.
Well, all right, I'm with you. 2, right? But yeah, I see what you mean. How many x's are left? 1, where?
On the bottom.
There you go. So what does a negative power mean? It means flip. So what is the best way to do a problem like this is to flip these up. What's the second best way to do a problem like we just did? Well, what do you do with powers when you divide? Don't you subtract them? The mistake people make is they forget they subtract 7 minus -5. Isn't that 7 plus 5? Which is 12, the same answer we got the other way. Maybe. So if I had 10 to the 15th divided by 10 to the -7, I could either do 15 minus -7, or I can make this 10 to the 15th times 10 to the 7th. Either way I do it, I get 22. I like doing it this way because I take the negatives out and I don't make them a negative mistake. Okay, does that help on number 13? So those are some rules of exponents that are easy to forget. Yeah. All right, maybe. Any other questions, guys? I've silenced the class. I'm sorry. All right. All right.
Sure,
Uh,
sure.
what's
So number 12, please.
12 in the same.
Yes,
what,
2B, page 102.
what about people living in a big city?
Yes. Live in a big city with a population density of 15 people per square
So-
kilometer.
Yeah, on the surface of that, does that make sense? If you live in a big city, would you expect there to be 15 people per square kilometer? Does that make sense?
No,
Nope. So you can just say real quick, no, I'd expect more, right? That's all you
a
gotta
lot
say.
more. Yeah.
Yeah, there you go. So that little like make sense section, most of the time it should be kind of a quick answer like that. Question 11 from 2A. Where was 2A? It was like 80 something. Here we go. I bought the fabric at Xmart. You should have got it from S-Smart. Xmart, because their price of $3 per square foot was better than Mart's price of $15 per square yard. Yeah, so that one might take a little bit of work. What do you have to do on number 11 to be able to compare those? So they, well, I don't know what that means. So they tell me Xmart, it's $3 per square foot. And Mart, it is, what was it, $15 per square yard. Why can you not just directly compare those?
Those are two different units of measurement.
Yes, the units of measurement are different, so you should pick one and do what to it?
Convert it.
Convert it. So just pick whichever one. Let's just do this one. So $3 per square foot, and I want to make that into per square yard. So I don't want these here anymore, right? So I can do that thing we talked about yesterday, foot, yard. Is everybody with me out there? Because I can't
Yes.
compare them.
Yes.
So I take either one. It doesn't matter. You could have made this one into per square feet. I just chose that one. So 3 feet in a yard, 3 feet in a yard, 3, $27 a square yard. Shut up, Jeff. So is X better now?
No.
X gonna rip you off. X gonna rip you. Yeah. So it's no. It's so much worse. It's a lot worse, right? So that's just the cautionary tale of making sure the comparison makes sense.
So for this problem, do you only like, so for where it says 3 and then $3 and below that is the feet squared, do you put it on the bottom when you are already given the unit of measurement and you're trying to convert it to something else, or is there something
I
I'm
put it
missing?
on the bottom because it's on the bottom. I didn't have to choose. How is it set? The price is $3 per square foot. So it's on the bottom. It's not a choice I make. It just is. Isn't this $3 per square foot?
Yeah, okay, I get it.
Per meaning it's the division bar, right? So I can't make the choice. That's just what it is.
Can you do
Is that-
2B number 60?
All right, let's see. Wait, did I miss? Oh, there it is. Okay. Oh, somebody else had the same question. 103, I think, somewhere. Yeah. Oh, yeah. Everybody. All right. My first question to you is, did you find an example problem like this?
No,
Huh? Sorry?
no, I didn't.
Uh-oh. All right. So that's the first thing you want to do. So there's an
I was just saying
example.
I was just saying the question for Nikki because I didn't know if you saw it or not.
Oh, okay. So yeah, I did. I was just wanting to get through whatever I was talking about. So Nikki, did you find an example like that?
There's an example in the book. They do talk about the blood alcohol content, but
Yes.
obviously the struggle was still real. So
Gotcha. So here's just to summarize what they say. Blood alcohol content is grams of alcohol divided by milliliters of blood times 100. And 0.08, of course, is the legal limit. And 0.4 is death. You can still die at 0.38, but 0.4 is sort of like around there, you're going to die, right? So how do I calculate blood alcohol content? Well, do I know how many grams of alcohol? Check. Do I know how many milliliters of blood? Check. And then you multiply by 100, and that's the blood alcohol content. So that's part A. Is that all right? You're going to get something way over this.
So you have one number on top and one number on the bottom, and you multiply them by 100.
Yes.
You multiply both numbers by 100.
No. I don't have 200s. You do this, and then multiply by 100.
Okay, when you say do this, what does do this mean?
So this is grams of alcohol divided by,
Well, that's the
Right.
gram. Okay.
divided by milliliters, whatever you get, multiply by 100. If I wanted
I
to
get
do
it.
top
Thank
and
you.
bottom, I'd have to have 100 and 100, right? Yeah. Is that all right? All right. So if somebody drank 50 grams of alcohol and they have 6,500 milliliters of blood in their system, right? What's their blood alcohol content? What do you do?
50 divided by 6,500 times 100.
Yeah. So I'm
But
not
when
sure.
they talk about how many ounces of liquor and then his weight and all that stuff, then I get thrown off.
You ready? They tell you the first sentence, 8 ounces is 70 grams. The guy drank 8 ounces. So how many grams of alcohol?
It's 70 grams. Doesn't matter. They just tell us
Yeah.
extra information. Okay.
But it's 70 there, right? Yeah.
Alrighty. I'll try it
They
again
just
later.
want you to know for yourself. It's like, I don't know how many ounces I'm drinking at a time, right? But you probably should. But if you know how many ounces of hard liquor, that's the conversion between ounces of hard liquor and grams of alcohol. Yeah.
Okay. That helps. I'll It's pieces to the puzzle for later. Thank you.
Yes. So this one's got a lot going on. Which part of this doesn't matter for the math is the fact that the dude is 180 pounds. If he was weighed more, he'd probably have more blood or whatever, right? So something else would change. But that's all they said about a 180-pound man is because
Okay.
it's related to the other parts. Yeah,
Throw out the facts that don't matter.
pretty much.
Okay. Thank you so much.
All right. So that problem, I agree, is a freaky ass problem. It's also like right at the tail end before further application. So you kind of know it's going to be a freaky ass problem. All right. How's everybody else? Is that good?
You want to take
Okay.
more questions?
Yeah, sure. What's up?
57, please.
I can barely hear you. What's up?
7, please.
I can't say again. Sorry.
Hang on. Is my volume down? Oh, no, it's not. Number 57, 2B.
2B, number,
That is on page 28. It says the antihistamine Benadryl is often prescribed.
no, Nancy, I don't know what's going on. I heard you earlier. I can barely hear you.
Okay.
Where's your microphone? Just get closer.
Let's see. Can you hear me now?
It's about the same.
That is weird.
Can you just type it in the chat, your question?
Yeah.
So 2B number something. $57, okay. Is that the one? Let's see. Oh no, we haven't done this one yet. All right. So this one's got the thing about Benadryl, right? So Benadryl, typical dose for a 100-pound person is 25 milligrams every 6 hours. So following this dosage, how many 12.5 milligram chewable tablets will be taken in a week? Ooh, I love it. I enjoy it so much. You would, you asshole, Jeff. All right, so the key thing here for any conversion problem is getting the correct starting point. They give me a bunch of conversions. And I guess, now look, we have to assume we're talking about a 100-pound person, right? All right, I'm going to stop sharing so I can write some stuff. So, how do I say this? How many tablets taken in a week? So I'm going to start, I want to convert week to number of tablets. So 1 week is where I start. All right, so I got 1 week. And I want to convert that to number of tablets. Now there's a lot of different ways you can do this. You can do this in parts. You can do this. There's a lot of different ways to do this problem. Here's the very direct way to do this. What path do I take? So I want to go from weeks to milligrams because then I can go to tablets, right? So I want to go weeks and eventually I have to make it to milligrams because then I can get to tablets. What connects weeks with milligrams? What connects time with milligrams?
6 hours.
Conversion? Yeah, 25 milligrams every 6 hours. So I want to go from weeks to hours. So then there's days in the middle. So I want to go weeks to days to hours. Then this is specific to this problem. I can go from hours to milligrams, and then I can go to tablets. Holy shit. So I'm almost certain somebody out there did this problem without writing down what I just did, and he did it right. Because you can reason out how to do this problem without writing this down. But now I know how to set up my chart. 1 week. You could do it, Jeff, and then go to days. All right, every step I take, I know what to do here. Then I want to kill days, go to hours. Then I want to kill hours, go to milligrams. So the only real interesting place, I really want you guys with me. Weeks to days. Okay, week dies. Now I'm in days. Days to hours. Okay, days dies. Hours to milligrams. And this is where it's, what was it? 25 milligrams every 6 hours, right? That's the conversion that's not just always true. So now I'm here, and now I can go milligrams to tablets, and they tell me every tablet is 12.5 milligrams, right? All right, so then you can fill this shit in. I basically just did the problem for you. I couldn't stop myself. Is that the only way to do this problem? No. I'm almost certain that if you've already done the problem, you did it in like little bits and pieces and then connecting them together. That's beautiful.
I'm sorry.
This is sort of like all the bits and pieces all at once.
Professor,
Yes.
can you hear me?
Yes.
Oh,
Let me turn
hello.
my, hold on. I don't know what happened to you. All right. My speaker is way up, so nobody else make it sound. What's up?
So, can you just explain to me on the board, the little words on the bottom? We have weeks on the top, and then we have days and hours and milligrams and tablets. So I'm trying to write what is under the first days.
Ooh,
They're
you're
on
coming
the
in
board.
big.
On the board. 'Cause I just can't
Right.
understand what it.
Weeks. So
Okay.
I want to go. Yeah. Okay. So if you're cool with this, then this is simple. Weeks to days. So where am I going to put weeks? Here, so they kill each other. Days. Days to hours. Where am I going to put days at? Here, so they kill each other. Hours. Right? So I start at a week. Then I want to go from weeks to days. So I want to kill weeks. So I got to put them down here. To days, go up here. Then I want to go from days. So I got to put days down there to hours. Then I want to go from hours. So hours goes down here to milligrams. I mean, that's how this thing works. It's where you start, then you kill it and you replace it. You kill it, you replace it. You kill it, you replace it. The only way this way will work is if you know this. Now, again, this is not the only way to do this problem. So for example, did anyone look at this problem and say, all right, each tablet is 12.5. So 2 tablets is 25. So I need 2 tablets every 6 hours. Did anyone consider that? Do you see that though? So that's sort of like not setting up, and that's kind of like working from both sides in. That's kind of but it'll work. It'll work. So I'm not ever saying that this is the only way to do this. There are other ways to teach this out. Yeah.
Okay. Yeah, because there are some problems that I could do just that way. This is what's hard for me doing the chart. I'm getting it little by little, but it's all my life I've always done things the other way where I just figure them out.
Yeah. The chart
okay, so that's okay. Yeah, because this has been like a struggle for me trying to get the chart.
Yeah.
I'm getting it, like I said,
Listen.
but if I were to do it all the time, it'd be easier.
Yes. There are very few methods that I won't accept any other method except my method. The chart has its uses, and then it kind of sucks sometimes, right? And it's just the way we look at things. So 57, you could do that entire problem without any grid shit at all. You're doing the math that I'm going to do with my little grid thing, right? You're just piecing it together as it makes sense. I really want you to get this. There's always more than one way to do a problem. And the only times I require certain methods is if they're going to help us with more advanced problems later, or if a method hides too much, right? There are certain methods that sort of work, but you can't see why they work. I don't like those, right? But yeah, there's multiple ways to do number 57. Okay. You guys all right out there? Are you guys all feeling?
Thank you.
All right. We're over a quarter of the way through. We're like around 30% of the way through this class. Holy shit. Not today's class. I mean the semester. All right. If there's nothing else, even though there is something else, I think we got to keep going. Let's see, where did we end up? So we finished chapter 2. We got into chapter 3 a little bit. Let me see, where's my notes? Here we go. Oh, let's see, where's chapter 3? Here we go. Okay. So we talked about the is and the of stuff. We talked about percent change. I think that's the thing we ended up with, right? I think it's the last thing we did, if I remember correctly, was percent change, right? Let me see. Oh, okay. I want to see which problem I want to do first here. Yeah, okay. So let's just review quickly what we did yesterday. Put you guys over there. So if I needed to figure out 14% of 7, how would I do that?
Turn 14 into a decimal, then multiply it by 7.
Yeah. So you always got to use the decimal version, right? The actual number version. Of means times 7. Right. And I believe that's 0.98.
Yes.
Coolness. Okay, I like it. And then, of course, that kind of led up into something like 11 is 38% of what? Could you guys take a minute and try to set that problem up? There we go. And this is a beautiful example of the way I do it is not the only way to do it. I just legitimately believe it's the best way to do it. So what do you guys write now? 11
Equals
equals
0.38
0.38.
in parentheses.
Sure.
X.
I like it. Of means times what? I don't know. So X. And this is a very basic equation. I want to get X by itself. It's currently multiplying by this stupid thing. So let me divide by that stupid thing. And now I know what X is if I just do this. Is that 29 points and 28? I don't know.
Yeah, 28.
Really? Neat. What do you get?
28.9. So you should round to
28.9, blah, blah, blah. Okay.
Excuse me, what did you divide? You divided 11 and 38?
11 and 0.38. Yeah.
Thank you.
Sure. Okay, so that's some of what we did. And I think, is that the last thing we did? No, the last thing we did was percent change. So let's say there is a laptop originally $1,600. It's now what, Jeff? I don't know, Jeff. Why don't you do this to yourself? Give me a second. I'm trying to make something that 1472. Columbus sail the ocean blue. What's the percent decrease? What's the discount percent? What's the percent decrease? How would you figure that out? What's the
percent change divided by the original?
Be careful. Say that one more time.
Percentage change divided by the original?
No, we're trying to figure out the percent change. So it's the change divided by the original. I like it. Now, I really want to make sure the book says new minus original divided by original, something like that. And it comes out negative if it's a discount, positive if it's an increase, right? But if you just do change divided by original, I know the answer is going to be a decrease because I know it went down. I don't need math to give me a negative number and that tells me. So if you want to do it the way the book does it, that's fine. You're just going to get negative numbers, which just means it would be a decrease. So how much did it change by?
128.
128. And what was the original price?
1,600.
Okay, so that'll tell you what the percent. Well, this would be a decimal. You can make it into a percent. If I did it right, it should be a decent decimal.
Comes out to 0.08.
Yay! Which is
8%.
8%. 8% discount, not bad. Okay. All right, now, I think we're ready for this. Yes, let's do this. I'm going to erase this. So, if there's a hat on sale for, what do you got, Jeff? You can do it, buddy. Make it simple. There you go, buddy. $18. After a 10% discount, how much was the original price? Oh, shit. People always try to avoid algebra when algebra is basically the only real way you can do this. Is anyone right now thinking about taking 10% of 18 and adding it back on? If you are, let that thought go. I want you to really see why this makes sense. What did we take 10% of to get here?
The original price.
The original price. Was the original price 18? No, it was higher than 18. I really want this to make sense. So if you do 10% of 18 and add it back on, you're never going to get all the way back up because you're taking 10% of a smaller amount.
Oh my gosh, that's so easy to do. Oh my gosh. Yeah.
Uh-oh.
I mean, what you're saying is so true, and it's so easy to not see that.
Yes.
Right? If you're
So
in a store, you see a sign like that, you wouldn't think that.
I know. And trust me, people use this fact. People know other people don't understand percentages, and they use that to their advantage every day. Holy shit. Anyway, all right. The actual way to do this is going to be a little bit harder because we don't know what the original price was. So here's the full tech. Oh, I'm sorry. Good, Nikki, go ahead.
Can you just do 18 divided by 9 times 10?
Wait a minute. 18 divided by 9 times 10. Sort of. And what you've done, Nikki, is you did sort of a shortcut, which is going to be the second way I was going to do this. But if there's a 10% discount, how much of the price is left? What percentage of the price is left?
90.
If I decrease
90.
Yeah.
90%. So 18 would equal 90% of the original price. Now let me work my way up to that. So now watch. What was the original price? We don't know yet, right? So what was it?
X.
X. Kick ass. Didn't I subtract something off to get to 18? Isn't that the whole idea? Isn't that how a discount works? You take the original minus something to get to the sale price, right?
Yeah.
What did I subtract from this? I subtracted 10% of this.
Can you repeat that, please? That one part? What did you subtract?
How do I always, so quick little side note, watch. If something costs $10 and I have a 20% discount, how would you figure out how much it's going to cost now? Wouldn't you take 20% of 10, right? You would take 20% of 10 and subtract that from 10, right? That's exactly what I did. I took 10% of the original and subtracted it from the original to get the sale price. Now let me catch up to Nikki. What is a whole X minus 0.10X? What's $1 minus 10 cents?
90x.
Yeah, so 0.9X. And so this is what you would do. So yeah, technically, this is the idea of how we calculate sale price, isn't it? Original minus discount gives me sale price. Well, what am I discounting it? 10% of what it was. What was it? X. But you can actually start here. If I have a 10% discount, 90% of what it was is left. But you see how those are the same thing. So it doesn't matter which one you start at. Oh, Jeff. Oh, shit. All right. So $20 is what it was originally. Does that make sense? Well, what's 10% of 20? 10% of 20.
2.
2. 20 minus 2 is 18. So that makes sense. So if you don't know the original price, you can never get there by doing the percentage of where you ended up. It's never going to be enough. Okay. You're like, that's how I feel about my work on my homework, Jeff. It's never enough for you. I know. It's true. Okay. So there are going to be a couple of purely algebra problems. Go ahead, Nancy.
Are we going to go over this again?
Sure. Let's do one more problem.
Okay, thank you.
Let's do a markup problem. So we have a store and we pay $50 for something. We mark it up. Ah, shit, Jeff. I started with the answer. Hold on. That's the part I should have kept in my head. We mark up the price. So let me change it in my head now. We mark up the price by, what do you got, Jeff? Let's do 8%. And the sale price is now what, Jeff? Oh, God. Let me think. Come on, hold on. 1, 2, 1, 2, 3, 20. Yeah, sure. Let's see if this works. 43.20. So we mark up the price by 8%, and the sale price is 43.20. So what was the original price is the question. Holy shit, Jeff. That L. Get over there. So the neat thing about algebra is we pretend like we know the answer. What was the original price? Tell me, what was it?
Probably $50.
Huh? No, don't give me no probably. What was the original price? X.
I don't know.
Yeah, you do. It's
X,
X. There you go. So that's why algebra is so freaky. Because we say, you know what it was X. And now I can do shit to X. That's the key. So what am I going to do to X? I'm going to mark it up by how much to get to 43.20. How much am I going to mark it up by?
$8%.
Yes, 8% of what then?
43.20.
No, that is where I end up at. How did I get there? If I have something that costs X dollars and I mark it up by 8%, that's 8% of what it is.
Of X.
Okay, can you
Yes.
repeat what you just said right there, please?
Yeah,
If
so-
you,
Now look, if I know it's $100, stay with me. If I know it's
Yeah.
$100 and I want to mark it up by 8%, what would you do 8% of?
100.
Yes, what it was. You would do what the original times 8%. Well, what's the original price here? X. So how much are you going to mark it up by? 8% of X.
Okay.
So stay with me. Watch. So if it's $100, you would do 8% of 100. That's how much you would increase it by, right?
Mm-hmm.
Right. What if it was $200? And I increase it by 8%. What would you do? 8% times 200, right? Right? No? What's up?
Yeah.
Okay. So does this number really matter?
Yeah.
I can put whatever number I want to. If I'm going to mark it up by 8%, it's 8% times that. So what if it's anything? If I mark it up by 8%, how much am I going to mark it up by? 8% of what it was. X just stands in the place of this number that I don't know. But what do I do every time I know the number? I multiply by 0.08. So what am I going to do when I don't know the number? I multiply by 0.08. That's the rule. That's what we do. Now, what's wrong if I do this? What's wrong with this? Is our business going to do well if I do this? What have I actually added on? I've added on
8%.
No. I have not added on 8%. I have added
8
on
cents.
8 cents. Yes,
What?
8 cents.
Oh,
That's not good. Our business is not going to do well if I just mark it up by 8 cents. I got to mark it up by 8% of what? Now that's better. So that by itself doesn't mean it just means 8 cents in this case. That means 8%. Now I might make a profit. And now what's 1x plus 0.08x? That's nice. One plus 0.08. 1.08. That's crazy. And I want you guys to realize you can always start here. If I marked something up by 25%, that's 1.25. Right? If I mark something up by 17, it's 1.17. So if I mark something up by 8%, it's 1.08. It's 108% of what it was. And now I just do like we did before. I divide by 1.08 to see what the original price was. And I know my answer should be less than this because that's after a markup. So I kind of know if I get 50, I did something wrong. So I think you should get 40, right? Yay, Jeff. So the original was $40. We marked it up by 8% to get it to 43.20. Okay.
$40.
So do you guys notice if it's a markup, it's X plus percent X. If it's a discount, it's X minus percent X. And that makes sense because that's what we would do if we actually knew the original price. Okay, all right, maybe. Why is that worse? Because we don't know the beginning. That's what algebra is for. And those kind of problems are always the worst. If I don't know where I started, the math is going to be more disgusting. Of course, it makes sense. So it's not algebra's fault. Algebra's doing what it can with what it knows. Okay. Let me see. Let me do a little bit more, and then we'll take a break. Yeah, here, this is a key thing. All right, how do I want to say this? Whoa, Jesus. Let me see. Okay, let me do this. So we hear this all the time in the news, this kind of thing. If percentages change, that's where things get a little wacky. So if I go from, if 3% of, if there's a 3% infection rate and it goes to 4%, right? So the 3% infection rate increases to 4%. You can actually state the change in a few different ways. Do you understand? One way to say this is it increased by 1 percentage point. So one way to state this is the infection rate increased by 1 percentage point. Have you guys ever heard that before? Percentage points. So it went from 3 to 4. It makes sense that it went up by 1 percentage point. That actually is the most honest way to discuss this change. The second way is not incorrect. It's a little less honest, though. How do I calculate percent change again? Right, we started off this lecture with this percent change is the change divided by the original. So it changed by 1, and what was the original?
3.
3. So you could say it changed by 33%. So you could say the infection rate increased by 33%. And you would technically be correct, but do you see how that communicates the wrong message to people listening? Yes. Right? And this type of thing is used all the time, and people will say, I did the math right. You can check my math. And I'm like, I understand you did the math right. you're just communicating the wrong way. I mean, that's what really sucks. What really sucks is when somebody does the math right, but it's this. So this communicates the same thing this does, it's just this is much easier to comprehend. And if I say it went up by 33, you're thinking it went up to 36%. We're almost 50%. Holy shit. You know, it's like, no. Now, of course, most misinformation about COVID is making it sound not as bad as it actually is, but in this case, it makes it sound worse. Yeah. So it's just that idea. All right. So there are two ways to communicate changes in percentages, right? This way is by describing the absolute change in percentage points. So that word point means you're looking at it purely absolutely. It went up by 1%, 1 percentage point. This, it did go from 3 to 4, which is a third. A third of 3 is 1. It is 33.3% increase in the number, but that's not honest. That's making it sound worse. Okay, maybe. So it's this idea of percentage point change and percentage change. So when percentages change, that is weirder. That is a few different ways to say it. Okay. All right, maybe. Where's that problem? I made a problem I wanted to do with you guys. Dadgummit, Jeff. Where did you put it? Here it is. All right, let me see if you guys. All right. So that's that idea. So when percentages change, you can either describe percentage point change, which is just purely the absolute change, or you can do a percent change of the percentages, which mathematically is right, but it just communicates the wrong thing. Okay. Now, I want to do a quick little problem, and then I think after this problem, we'll take a break. There's taxes are so misunderstood. The very first thing I want to tell you guys, do you guys understand how taxes work? I want all 15 people here today, and I'm hoping that the little black box name people are actually here, to really understand what I'm about to say. If you make $1 more and go into the next tax bracket, you are paying the same taxes you would have. You don't suddenly get all of your money taxed at the higher rate. Do you guys understand what I'm saying? Politicians continuously make it sound as if we're taxing somebody's complete income when we raise the top tax rate or something. No, we're only taxing the money above a certain amount of money. Are you guys with me a little bit? I'm not going to make this a business class. So that's one thing I want you to realize. Okay. Don't let politicians say, oh, they're going to tax it. No, if I'm going to take 80% of your income above $5 million, I don't give a shit. I'm sorry. I'm letting some of my personal opinions in. I'm sorry. But it's just the miscommunication. That is not my personal opinion. It is true. It is a miscommunication, and people don't understand. Here's another level of this, though. All right. This is another miscommunication of percentages. Let's say there's a little island. And there are 100. Let me see. Yeah, there's 101 people on this island. Right? One person makes $100 a year. This person is just wealthy. It's insane, right? 5 people make $10 a year, and then 95 people make $1. You guys with me? And the way their tax system is set up, this person pays $15 in taxes. These people pay $1 in tax, and these people pay no dollars, no taxes. This roughly mimics our tax system, but I mean, really, really simplified. Okay, now, what is these people's tax burden? What percent? So how much total money did the island government take in? Not $16, right? It took in 15 plus 5. It took in $20. Are you with me? So the island government collected $20. Are you guys all with me? Some of you guys have tuned out. You're like, oh my God.
Can you say that one more time?
Sure.
You said about the $20.
This one person paid $15, right? In taxes. These 5 people paid $1.
Oh, okay.
So that's $20.
Right.
Now, this is what you'll hear on the news. These people have a tax burden 15 out of 20. What is 15 divided by, right? $15 out of $20 total taxes. That is 75%. You with me? So you'll hear this all the time. Oh, these poor people, they pay 75% of the taxes. How much of the money, how much of the total money did they make? So how much total money was made by everybody? 150 plus 95, right? Let me see if you guys are with me. 1 made 100, 5 made 10, and 95 made $1. So how much total money is that? $245, right? So they took in 100 out of 245. How much is that?
I'm sorry, I lost you. How did you get the 245?
Oh yeah, so one person made $100.
I got it.
5 people made 10, that's $50. 95 people made 1, that's $95. So how much money was made total by everybody on the island? $245.
Is it 40% for the 100 divided by 245?
Yes. So this actually, do you think this is unfair, this tax system, just looking at it? He made 10 times as much money. You could argue it's maybe unfair. I could have done this a different way. But it's not like crazy unfair here, right? It makes sense these guys don't have to pay anything at all. It makes sense that this person should pay the most. But you'll see them talk about these percentages as if, and then you got to say to yourself, what should it be? What should the burden be? Again, okay, that might be going too far. It's just this idea of they'll say percentages, but you don't have any clue as to, well, what should it be? What would make sense? Why does that not make sense? Right? All right. I didn't have the firmest point on that example, but it's too bad. It's just this idea of different ways to calculate percentages of things to make things seem a certain way. And it just makes me so sad that if people understood a little more about percentages, less of us would be duped by these things. That's my PSA announcement for today. So let's take, how long of a break do you guys want? Let's see. Want a 20-minute break?
Sure.
Okay, come back at 10:30. All right. Go to Canvas right now. This might not perfectly match up 100%, but I want to show you something kind of nifty. All right, Jeff, what are you doing? There you go, buddy. Old man Jeff. Here we go. So if you go to modules and go to unit 3, there's something called Math for Science. So I every semester I do some workshops for students in science courses, and it's kind of like a review of science. A review of math that they'll need for science. The interesting thing is, a lot of what we're doing here is related to this. So there's like exponential notation, rules of exponents. We're about to talk about scientific notation. So that's in here also, how to convert, using your calculators with scientific notation, multiplying and dividing percentage. And then we're also about to get into something called significant digits or significant figures. And the way the book does this is just dumb. I'll just say that. So I kind of enjoy this, and not just because I helped put this together. It's interesting how it overlaps a lot with what we're doing. There's conversions in part 3 of this, and so forth. And then there's some like, other graphing stuff and whatever. So it's not a one-to-one match with our class. You with me? But it's just it just had some stuff that kind of goes along with what we're doing. Okay, so that's up there if you want to look at it. If you look at it like, I don't like that shit, never look at it again. It's that easy. So I had a request to do, before I do anything else, there is a quiz today, right? Of course, because that's just the way things are. And like I said before, it is going to work this, and let me share Canvas again. It's going to work the exact same way the first one did, except we're not taking it together. You're taking it by yourself. So no cheating, no using the book, no using notes, right? You shouldn't use anything except what's in your head, some scratch paper, pencil, calculator, and the quiz. So the way it's going to work, I don't think right now you can see it. Let me become a student. If I look at my quizzes, I don't see it yet. See, there's just quiz 1. Now let me stop being a student, and I'll be the, ooh, look what I can see. Well, let me publish. Now I can see quiz 2. Ooh, so the way this is going to work, I've given you an hour to do this. Oh shit, I don't want to show the questions. Okay, good. Oh shit. There we go. Where are my instructions at? This is not good. Is somebody chatting at me? Don't do that to me. I can only do so many things at once. Darn dadgummit. Why are the instructions not there? This has got me concerned. All right, let me stop sharing for a second. I gotta make sure it's all up there. So it's the way it's gonna work is you will have an hour to do it. It's due by tomorrow morning at 7. Oh, it's okay, don't worry. It's due by tomorrow morning at 7. So you could start tomorrow at 6, and then you have until 7, but you better turn it in by 7. Is everybody with me? For some reason, I'll have some people doing it at 1:30 a.m., but that's whatever it fits in your life. I just gotta make sure, what happened here, Jeff? Why are the instructions not there? I probably should put the instructions in there. So I'll do that before I open this up. Let me do that right now. So just give me a minute. Hold on. I thought for sure I did this. What happened? Freaking computers. Why should he do that? Let me see here. Bam. I did do this. What happened? 1 hour. Please don't tell me. Sorry, everybody. Oh man, this so sucks. Everything's gone. Here we go. This is still here. Good. I'm not really sure what happened here. Okay. All right, 7 a.m. tomorrow. You'll be able to see it starting at, I'm going to make it 11:45 today. And it's due tomorrow at 7 a.m. I want to try to get them all graded before class starts. And you'll have an hour. It shouldn't take you an hour. I'm just giving you an hour so that any technical issues you can work through. Oh, I love it. Okay, so that's not really okay. Let me see.
Professor, how many questions are on the quiz?
Oh, I don't know. Let's see. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, I mean, an hour is too much time, but you know.
Not for me.
All right, well, it just is. Yeah. So you should definitely be able to do it within that time frame. And if you have technical difficulties and Canvas just won't let you submit it and your time is running out, email it to me. And then keep trying to submit it, because then at least I have a timestamp, right, of when it was done. Okay. So this will be exciting. So at the end of class, it'll open up. You could do it. You can start whenever you want to between now and I'd say 6 a.m. tomorrow, because you have an hour to do it the minute you open it up. So everybody, any questions about that? That's the same way that the rest of the quizzes are going to work. That's the same way the midterm is going to work. Okay. All right. I love it. Everybody I can see is looking down. This is kind of weird. Am I in your lap? What's happening? Okay. Now, I did have a request during the break to do another problem like we don't know the original price and it's marked up by so much. So let's do one more problem like that. And then we'll get into scientific notation, right, which is section 3B. All right, give me a minute. Let's see. Here I am. Just go over there. So if we mark the cost of a car up by 6%, the sale price is, what do you got, math boy? Let's see. $1,800, 31,000. Yeah, I'm just making it easy on myself. Let's see if this works. What was the original price? I hope by now you guys understand, if you don't know the original, you cannot just take the percentage times the number you see, and that means shit, right? You should know by now that is the wrong way to do it, right? So take a minute, try to set this up. I don't want to see, yeah, this will be neat. Oh, that doesn't work then, does it? Yeah, well, maybe it does. Okay. That's so cool, dude. Yeah, it's funkadelic. That is funkadelic. Sorry. All right, let me catch up for you guys. So what was the original price? Don't tell me the number. Tell me how to get this started. What was the original price?
X.
X. And I'm gonna mark it up by 6%. So this is what am I gonna put here?
In
Plus.
addition-
0.06x.
Good. And that together, so if I start at the original cost, I mark it up by this much, I should end up at the sale price. So then you do that, right? X plus 0.06x is 1.06x. You divide by 1.06 and you should get 30,000.
So, okay, this is where last time I lost it and then I got back on board. So can you just repeat that slowly, please? So we're
Yeah.
basically taking the same thing. 0.06. Okay. Okay, go ahead.
You're cool with this, right? If the original price
Uh-huh.
marked up by 6% of the original price.
6% of the original price. So we just basically got the 6%. And how do we get this 0.06?
Well, that is what 6% is.
The 6%. Okay, so we just put that in there. Okay.
So the math can't use this made up number. It has to use the actual decimal that it represents. Yeah. So you get an x plus 0.06x is just 1.06x. I'm just combining like terms. And then this is 1.06 times x. So then I have to divide by it to get rid of that. So now I know what x is.
Professor,
Yes.
can't we just multiply 31,800 times 1.06?
No, of course not. You would not get the right answer, would you? Right? I mean, so this number, I am never doing a percentage of this number, am I?
Mhm. Yeah, I get that.
Yeah, I took 6% of the thing I don't know. See,
Okay.
even there. Yeah.
Okay, okay, how do we get if we have X, we don't know what X is. How do we get the 31,800?
No, they told me.
Oh, okay, so they told, yeah,
So,
okay.
listen, if something costs so much money and I increase it by a percentage of that, that will give me this new price. So they told me the new price. They just didn't tell me the original, the old price. The funny thing is, all right, let me let you guys copy this down, and then I want to show you something. All right, I'm going to erase this setup here. All right, now, can you guys now look? If there was something that cost $100 and you mark it up by 20%, can you figure out what it comes now if I mark it up by 20%? What's the cost? What's the amount now?
$120.
So what you do, you did 100 plus 20% of 100, did you not? Right? If you look at what you did, that's what you did, isn't it? And that gave you
Yes.
120. This problem is saying, did I know the 120 to start with? No, I had to
No.
figure it out. This problem is saying, okay, I'm not going to tell you the 100. I'm not going to tell you this. It's going to be X. but I am going to tell you the result was 120. I mean, do you see how that's the format? Why is this the format of this kind of problem? Because that's what we do. To mark something up, I do that percentage of it plus it, that percentage of it plus it to get to the new price, right? And the only difference if it was a discount is that would be a minus. Okay. So now watch what I can do now. You ready? So if I said I mark something down, let's say I discount something by 15% and the sale price is $11. Bam. I discount something by 15% and the sale price is 11. Solve. It just sets itself up. And you're all like, okay, yeah, math boy. It does that for you. But I really want you guys to see this is a sentence. If I take something and decrease it by 15% of it, I end up at 11. That's exactly the sentence that says. Okay.
I'm sorry, I had to charge my laptop. Can you just repeat that just really quick, please?
Yeah, I'll do it that for one. If I have something and I mark its price up by 8% and I end up at $40, bam, I solve that equation. So if it was I mark it down by or I discount it, that would be a minus. So these kind of problems are always going to have this form. Why? Because this is what we do in real life. Yeah. Okay. Okay.
Hey, Professor.
Yes.
Question. So when it's a discount, okay, hold on. For the markup, there's like an invisible one in front of the X, correct?
Yes, there always
Okay.
is.
Why isn't there an invisible one when there's a discount?
There is. There totally, of course there is. So,
because like for one of the examples, it was the hat on sale for $18 with a 10 discount, and there was no like, unless we did and I just missed it, but we didn't add the one.
No. Tell me, what was the discount amount?
10%.
10%. Okay.
Yeah.
What is 1x minus 0.1x? 0.9x. That's where the 0.9 came from.
Oh. Okay.
So of course that's a 1. Yeah.
Okay.
In fact, you can always, I mean, there's 1.0
Right.
minus 0.1, and there's where 0.9 comes from. Yeah.
Gotcha.
Cool. So it's always a 1 there. It only shows up really if we need it to. Yeah. Okay. But it's always there. Poor little 1 dude. All right. Anyway, I did want to, this would probably freak you out. I don't know. During the break, I just discovered some math I had never thought of before, but I'm not gonna show it to you. I don't even remember where I put it. But I've developed a shortcut for myself for doing these kind of problems that I never really thought about before. But anyway, that's what you can do, kids, if you knew math. Anyways.
That must be really exciting, you know?
It kind of is.
Be able to do that, and you know, that's exciting. I'm happy for you.
Oh, thank you. It's okay if you're not. It's like, however you want to live your life, Jeff. Sounds great. Fill it with that shit. All right. So let's do this. Let's get into, I want to do the next couple of topics, show you what it looks like in that booklet that I uploaded, and then we'll probably call it a day. So now, here's something interesting. Let me get into this topic without even saying again what it is. I just wanted to make sense by itself without any definitions or shit. How would you write 4,000? All right, let's get really, really silly. You ready? Isn't that 4 times 1,000? Is that remarkable? Is that insane? That's holy shit. All right. And isn't 1,000, how many tens does it take to make 1,000?
100.
10 times, 10 times 10 is what?
100.
And 100 times 10 is what?
1,000.
So it takes 3 tens, right?
Oh,
Is everybody cool with that? Let me stop for a minute. Does anybody have a problem with anything I just did? All right. So if I really wanted to, I could always write 4,000. I could just write it as 4 times 10 cubed if I wanted to be really weird. So now watch this. What if I had this number? All right. Holy shit. There's 1, 2, 3, 4, 5, 6, 7, 8 groupings of 0, 0, 0, right? What is kind of not important? All the freaking zeros really aren't important. What's important is sort of like what place the 8 is in, right? In fact, what the shit is this number? I don't know. To be honest, I probably lose it around here. I don't even remember some of the larger stuff. Septillion and stuff like that. All right. Could I write it like this? Yes. I really want this to make sense. Do you see how there's 1, 2, 3 zeros?
Yeah,
And that,
can't
of
you
course,
just do it to 8 times 10 to the 8th power?
Careful. How many zeros are there? 3, 6, 9, 12, 15,
24.
18, 24. So can you see how I don't give a shit how many zeros? If I had 7 followed by 82 zeros, it will take just as much time to write it as it does to write this one, as it does to write that one, if I write it in this form. Do you understand the importance of that? So if I'm talking about distance between stars, we are talking huge amounts of miles. I don't want to write all these zeros in my paper, right? Unless I have to have it a certain length for my teacher. But no, I want to just write it like this. If I was an astronomer, the most important part of this number is this one. It tells me about how big the thing is, right? This number almost doesn't matter.
sir, where did
Yes.
7 times 10 come?
Oh, I'm sorry. That was just an example. If I did have a 7 followed by 82 zeros, I would much rather write it like this, right? I don't want to write 82 frickin' zeros. I just want to have a way to tell people how many zeros there are, right? Okay, so this format of writing fractions is called scientific notation. So scientific notation has to be a number from 1 to 9, and it could have a decimal with other numbers, times 10 to the number, right? That's a horrible, but oh well. I like to think of it as, all right, this is going to sound weird, and I really don't care. I like to think of it as sucking all the 10s out of something. So I suck all the 10s out of this and put it right there. So it's 4 with a bunch of 10s. This is 8 with a bunch of 10s. So if somebody did this kind of problem and they got this answer, is this correct? Does that look like it matches the right format? Does that match the format?
Yes.
No, 78. 78 has a 10 in it, doesn't it? All right, so let's get a little more specific now. This idea is not just the number of zeros. It's actually the number of times you move the decimal. So let's get a little more specific. Where's my eraser is completely just, what have I done to myself? There it is. Okay.
Professor, what you wrote up there where you have the hashtag, the dot, and then
Number, sorry.
okay,
I know nowadays that means hashtag.
Yeah, I know. I'm sorry. So sorry. A number under 10, right? Can you repeat how you explained that sentence? A number under 10 times.
Yeah, 1 to 9, right? That's why it's a single digit.
Number 1 to 9.
point, and it could have other numbers after the decimal, but this has got to be a single digit times 10 to the something. All right.
Yeah. Thank you.
Sure. Now, before I go,
Hashtag. So sorry.
that's all right. That's all right. Hashtag living life. All right. Sure, let's do this. So what if I, real quick, if I have this, can somebody tell me what that looks like as a fraction?
4 over 1,000.
Yes, tens, hundreds, thousandths. So isn't that 4 over 10 to the third power, just like we did? That's not in the right format, though, is it? I need to move these up. And in order to do that, the power becomes negative because we know a negative power means flip. So the way I like to look at it is, he's happy down here. I'm pushing him up. He's upset now. Whatever the shit gets you through, right? Okay. Now watch what this means. A negative power means the number was originally small, smaller than 1. A positive power would mean the number is bigger than 10, right? I was taught left and right. I still have trouble with left and right. I have to do this on the steering wheel if somebody's giving me directions. Turn left. Okay, that's an L. So this way. Okay, good. I don't mind telling you that. My brain is full of other shit. Some point that was just thrown out, right? So now I have problems with that. So here's the more technical way to do this. If I want to convert something like 483 million to scientific notation, here's the correct way to do this. Where's the decimal currently?
At the end.
Yeah. How many times do I have to move it until I have 1 digit in front of it? So I'm going to end up right
6.
there. No,
Oh.
6 would 3,
9.
6 be right there.
8.
Yeah, 8.
7, 8. So 3, 6, 7, 8. So this would be 4.83 times 8 tens. Because what happens every time I multiply by 10? Doesn't the decimal move forward? Right? So doesn't this recreate this number? Because if I move the decimal forward 8 times, don't I get this? Why was that positive? Because it's a big number. I could say because we moved it left, but like I said, that actually is, even if you know left and right, that's a dumb way to think about it. Positive exponent means big number means positive exponent. All right, so how would I convert something like this bad boy? Same way. I want to move the decimal until it's behind what?
The 7.
The 7. You always want to move it until there's 1 digit in front of it. How many times do I have to move it to make that happen?
9.
9 times 11. So 7.28. Why is this wrong?
Because you moved it the wrong way.
Oh, I see what you mean. Yeah, because this is a small number, it should be negative. So I really want this to make sense. If I multiply by 10 to a negative number, I'm actually dividing by 10 that many times. Every time I divide by 10, it goes back 1. So if I divide by 10 9 times, it's going to go back 9 times. These are the same. They're the same number. It's just this way is quicker to write. Plus, it communicates the important information. If I had a lot of numbers with a whole bunch of zeros, it would be very difficult to compare them, right? Can you look at this number just on site, this number here, and this number here? Well, I sort of maybe could, but if you just glanced at this, could you tell which one was smaller? No. But if I write them both in this format, I can see who has the bigger negative power. That would be the one that's smaller. I don't know. Are you guys semi with me? So this would be like for physicists or chemists that are talking about distances between electrons or something. Stupid small distances, right? Okay, maybe. Okay. All right, now, what about, all right, here we go. What about this? How would you do this? Do not convert them to numerical form, right? Don't convert them. That doesn't make any sense. So watch, this is how you do this. What's 2 times 3?
6.
6.
Crazy. And then what do you get when you multiply the tens? What do you do with the powers?
Add.
Add them. What's 11 minus 17?
-6.
Okay, done. Yay. Isn't that, can you imagine if I had 2 with 11, 0, I got tired, and then 0.0017. Isn't it much better to write it like to do it like this? Can you imagine trying to do this shit by hand? Screw that shit. I'd much rather have this. It gets to the important pieces quicker. Okay, maybe. Okay. All right. So there will be some convert to scientific notation, right? Oh, we haven't done the other way around. Can you convert 4.07 times 10 to the -7th? Make that into just a normal number. And then I want to show you a nice shortcut with this.
Would it be moving the decimal point back 1 and then adding 6 zeros, rather?
Oh, yeah. That's the shortcut. I love it. So since it's a negative power, you want to make this smaller. So you're going to move that way. So you got to move that way 7 times. But here's a smart thing. You're always going to have to move it back once to get around the number. So how many more times? 6. So there's always going to be 1 less than this zeros in front. So you have to move it 7 times. Then you're 1, 2, 3, 4, 5, and each time it's another 0, 0, 0, 0, 0, 0. So how many zeros will there be in front of the 4? 6 of them. I had to move once here. So there's still 6 more times to go. So it'll be 0.00000407. Become a thingamajig there. Why does it make sense? It's small because it was a negative power, right? Oof. And be careful. If I said to do this one, don't just put 6 zeros at the end, right? How many zeros in this case will there be?
3 more?
Yeah, you got to do 1, 2, 3, and then 3 more times. So there'll be 3 zeros. How's everybody doing? That's not horrific. You guys have talked about scientific notation before, right? Some of you guys? Has anyone seen this before? Nobody?
I saw it this morning when I was reading, or last night.
Saw it way back in the day this morning. Okay. When I was slightly younger, it was a good morning. All right. So
Can you explain that one just one more time, please? Just
this one?
Yeah.
Or that one?
You
This
said
one.
about 1 0 less part, the 1 0 less.
All right, now listen. There's a shortcut involved here, but let's just not even think about the shortcut. This means it's got to move 7 times back.
Yeah. Uh-huh.
I have to move it 1, 2, and every time I do another one is a 0.
Mm-hmm.
So that kind of gets messy. So one thing to realize is, aren't I always going to move it once to get around whatever number that is?
Mm-hmm.
So how many more times do I have to move it? 6 more times. So that means there's going to be 6 zeros, right? Once and then 6. Because I have to move it a total of 7 back.
Okay, got it. Thank you.
Hit gas. All right, I like it. Hey, Mikey. Okay, now comes the exciting part. Has anybody ever taken any science course and talked about significant digits or significant figures? Never. Okay, so here's the idea behind significant. In mathematics, we call them significant. You can do it, Jeff. Significant figures. I'm sorry, math, we call it digits. Got it. I'm a scientist and a mathematician, so it's weird. But in science, they call it significant figures. So in the pamphlet I put up there, it's going to say figures here. Who cares? Here's the idea. Let's say that there's 2 research teams go to Antarctica, and they measure the amount of oxygen in these ice core samples, right? And let's say team A gets this measurement and team B gets this measurement. Mathematically, did they get the same measurement? Mathematically. You can do it.
No.
Numerically, are those the same number? You can do it. Yes, totally, of course, because I can put as many zeros after. So math looks at this and says, okay. Now, think about this. Which team seems to be communicating that they are more certain about what they measured?
B.
Why?
Because it's specifying the 0 after the 3.
Yes, they went further in, right? What I'm about to say is nothing you'll ever have to do. Let me just explain the idea. So this team seems to be saying it's somewhere between 0.025 and 0.035. Do you guys kind of see what I'm saying? Whereas this team seems to be saying it's somewhere between 0.0295 and 0.0305 because they went one more place. They said, oh, we know that next play. We know it's somewhere between there. So they are a little more certain. So scientifically, there is a reason for communicating with zeros, and it actually means something. Mathematically, that 0 doesn't mean shit. But this is a way to communicate how certain you are. So significant digits is a way to determine how certain a measurement is, right? So whatever that method is, shouldn't the number for this be higher than the number for this one because these are more certain? This team is more certain about what they measured. So whatever the measurement, the sig digs should be higher for this. And I did just say sig digs. That's how we say it real quick. Sig digs or sig figs. Sig fig newtons. No sig fig newtons. Okay. Sig dig dug. I like sig dig dug. All right, now.
I like figs. like fresh figs off the tree.
Yes.
Just thought you wanted to know that.
All right. Here we go. You ready? How do I count significant digits? There's mainly two ideas here. One is if there's a decimal present, holy shit, Jeff. Start counting at the first non-zero all the way to the end. So like for this, for team A, what was their sig digs? Where's the first non-zero number? There.
The tenths.
Now count till you get to the end of the number. 1. So they have, how many sig digs? They have 1 sig dig. So what about these guys? First non-zero number is there. Count to the end. 1, 2. They have 2 sig digs. Technically sort of twice as certain, right? So it's just a very quick way to communicate how sure you are about a measurement you've taken. And that is important in science. So math just kind of goes, you're a weird science. And science says, hey, I got my reasons, right? Okay. Now, what's the second thing? Obviously, the second case is if there is no decimal present, right? Like it doesn't show up. So like a whole number. All right. So what if these same two teams? So the second case is if there is no decimal present. And yes, I know there's always a decimal. I'm just saying it doesn't show up. It's a whole number, right? So for example, and I'm not done here, obviously. This sentence has to go on. So let's say team A measures something to be 4,900 and team B measures it to be 4,910. They're both whole numbers, right? So they do some other measurement. You with me? They take their core sample, I sample, and they measure how much alien DNA is in there. Oh, yeah. Again, which team seems to be more certain?
B.
Team B, right? If somebody says, if I said to somebody, how many people are going to come to this thing? Oh, like 5,000. All right, they're not very certain. If I said how many people, and they said 4,900, they're a little more certain. If I said how many people, and they said 4,910, I'm like, holy shit, right? And this is how we communicate with each other. How far are we? Oh, like 50 miles. How far away are we? 27.6 miles. Holy shit, you must be on the Googles, right? On the internets, series of tubes. All right, sorry. So if there is no decimal present, that's a comma, not a presence. Start counting at the first non-zero. Stop at the last non-zero. Sort of like bookends. Start. This is all in that pamphlet thing, by the way. Start at first non-zero. End at last non-zero. Let's see if that matches up. So team B is the overachievers. Whatever theirs is should be higher. So here's the first non-zero, 1, 2. That's the last non-zero. So the sig digs there is 2. What about this one? 1, 2, 3. So they do have more significant digits. So these two are all you need to know. So let's do this. I kind of like this pamphlet because it does have problems and answers, which is really, really, really nice. So let me show you this. Oh, there it is. Okay. I got to still finish that up. Why is that still there? All right. Jeff, you'll figure it out someday. Where are you? So math for science. Oh yeah. So let me just show you where it is, and then I'll pull it up a different way so I actually do stuff with it. So that's how you find this little booklet thing, right? And again, you don't have to ever look at that if you don't want to. If you're like, I got enough shit to look at, then don't look at it. Let me pull it up a different way so I can do more with it. Oh, Jeff, where is it? There it is. Yay. Now, where did you go? I lost my class. My class is gone. There you are. And here we go. Yay. Just that easy, kids. Now, if you get to the Sig Figs, which is here, I give you the rules. If the number has a decimal point, if the number has no decimal point, right? I give you the rules. I give you some examples. So can you do this real quick? These 6 right here. Let me zoom in a bit. I just want you to tell me. I have no idea why the formatting sucks, but that's too bad for everybody. Can you tell me the Sig Figs for those 6 problems? While you do that, I want to check something out here. Sorry, let me go back there. Oh yeah, it's amazing. It's just gross. Yeah, the way the book explains it is really, really crazy. All right, so this problem is a you get it or you don't problem, right? So either you're done or you completely don't understand it. So what did somebody get for the first problem?
Is it
5.
3?
Yeah, it's definitely 3.
We're counting
Right.
the digits below.
Say again, sorry.
Never mind. I just gave the number. I didn't, yeah, add the total. Okay. It was a good reminder.
Okay. All right. So it's got a decimal. So you start at the first non-zero and you count all the way. So this has 3 sig digs. What about number 2?
Also 3?
No. It has a decimal. So you start at the first non-zero and you count all the way.
4,
4. And doesn't it make sense? Which team feels more certain about their number? Isn't number 2 team? They dared to go out to there. So they're like, oh, you guys must be more sure. You guys with me? So if there is a decimal, you count all the way to the end. If there isn't a decimal, you stop at the last non-zero, right? So number 3, there's a decimal. So I start at the first number that's not a 0 and I count all the way to the end. So what's number 3?
4.
There's 4 sig digs. What about number 4? There is no decimal.
So it's 3.
So there's 3 there. I start at the first non-zero and I end at the last one. In fact, what would this look like in scientific notation? Oh shit. Let me just mash these 2 things up. How would you make this into scientific notation? (1.25 times)
Third power?
Nope. 1, 2, 3, 4, 5.
5,
Remember, you always got to move that decimal until it's after 1 digit. Look at this. How many sig digs? That's 3 sig digs, right? So maybe. All right, maybe. It makes sense because if somebody else said 125,100, shouldn't they have more certainty than these guys do? And sure enough, this would be 4 sig digs, which means more certainty. All right, what about number 5? No decimals, so
Before
4, good. You start at the first non-zero and you end at the last non-zero. And what about number 6?
3.
3, good. You almost can't go wrong in this bad boy. I like it. So the way that I do things, there's just really two overarching things to memorize. If there's a decimal versus if there isn't, right?
Professor?
The book,
Oh,
yes, go ahead.
sorry. Okay.
Go ahead.
There in number 4, where you explained 1.25 times 10 to the power of 5th. Can you explain that just one more time, please?
Well, so all I did there was converted to scientific notation. So you would move the
Okay.
decimal 1, 2, 3, 4, 5. So that's how I got 1.25 times 10 to the 5th. And then you can see this piece has got 3 sig figs, right? Those zeros don't really matter. They don't talk about how certain you are. Okay, maybe. Oh, I can see some of you guys clenching up. All right.
How did you know to move it 5 times to the left?
Because that's how scientific notation works. How do I, holy shit, what did I just do? Scientific notation says you have to move the decimal until you are behind 1 digit. That's how
Okay.
scientific notation
Got it.
works. Yeah, yeah. So I never have to guess. I just always know that. So it's just a counting thing, yeah.
So you're behind 1 number.
Yes.
Okay.
And again, I know I'm weird, but I like to think of it as basically a 10 vampire. It's trying to suck all the 10s out. So if you stop too early, you've still got a 10. So if you stop behind 12, 12 is 10 and 2. It still has a 10 in it. I haven't sucked it out yet. All right. What'd you learn about in math today? Learn about sucking 10s. All right, now. Here's where things get interesting, right? You're all like, what? So when you start doing stuff like, can you guys see, have any of you guys ever seen The Weakest Link? Does anyone know what I mean when I say The Weakest Link, that show? It's a little while ago, I know. And don't call me boomer. I'm not a boomer.
Goodbye.
I'm not in that generation. Now, the answer to a problem of multiplication or division is based on the weakest link. So now look, 3.126. How many sig figs does that have? It tells you here, so you can't go wrong. All you have to do is read, right? Do you guys agree it has 4 sig figs or digs, right? I'm sorry. And then this next one has 2 sig figs. Which one of those is the weakest?
The second one.
Yeah, so then I have to round my answer to have 2 sig figs. My answer has to communicate the uncertainty in my numbers. So the answer has always got to show the weakest part. So do you see how you just do the problem? You just do this in the calculator and you get something, and then you round it to have the same sig figs as the weakest part.
So even if we encountered a problem where the top one had something ridiculous like 20 digits and the bottom one had 2, the answer would come out as 2 digits.
You still make it 2 sig figs, exactly. Because it's based on which piece is the weakest. So think about it. If you know that the cost is exactly $13.73 per person, and you're like, well, I think maybe about 20 people are coming. I mean, that means you're not really sure, right? When you multiply them, the answer should be representing the most uncertain you are, right? I don't know. Does that make sense? The answer shouldn't be crazy precise because there's a part of your problem that you don't really feel comfortable at all about. 20, I don't know. All right. Maybe not. Okay. So that's how all of those work. So that's how multiplication and division work. So let's do this. Before I talk about addition, subtraction, you guys try out number 5 and number 6. Why not? Let me erase this. So do number 5 and 6. By the way, all the answers to every problem in this booklet are all at the end. So if you want to do some more practice on your own, all the answers are at the end. They're on the last page. All right, let me catch up with you guys. And again, you do this in your calculator. If you're doing it by hand, that's fine. Getting some more practice. But if you just throw number 5 in your calculator, the first step is you don't even think. You just throw in the old calculator. What do you get when you throw in the old calculator? What do you get? Throw in the old calculator. What do you get?
5.05.
5.05. No thought needed yet. Now thought is required. How many sig figs does this dude have, the first dude?
3.
3. How many does the second dude have?
2.
2. So my answer needs to have the least. It needs to have 2 sig figs. Does it have 2 sig figs or digs?
It does not currently.
No. So wouldn't I have to round it to this place right there? And then it would have 2 sig figs. Do you guys see that? So I would round it to be 5.1. 1. Done. Okay, maybe. All right. Now do number 6. This should be a little bit funkier. So the first step is no thought required. You just throw that shit in the calculator. So what do you guys get when you just throw that stuff in the calculator?
116.22.
No, you get this, don't you? Now we'll finish up. Now the next step is which one has the least? Is everybody cool with that? Let's just throw in the old calculator, right? How many sig figs does the first dude have?
Excuse me, when you say just throw in the old calculator, that's what I was writing notes and I missed that part. We put those 2 numbers in. Do we multiply them or add them or?
No. What's it saying to do? I know that's a little bit of a weird symbol, but what does that symbol here mean?
Divide.
Yes, cool.
Thank you.
Yes, you're welcome. So then you do get the 116.22231. The first number has how many sig figs?
4.
And the second number has
5.
kick ass. So my answer should have how many?
4.
4 sig figs. I love it. So then watch this. Watch what I do. 1, 2, 3. Okay, I want to round to this place. right? I can just count my sig figs off and stop where I want to stop. So what do I get if I round it to this place?
Two.
2. Done. Okay. So it kind of makes sense. You don't want your answer to pretend like you're more certain about things than you are. Now, this is nothing you've ever had to worry about in math, correct? Because math does not give a shit. Math is just, here's the number, and you guys can round it however you like. But science tries to communicate a little bit more than just numbers. Okay, of course, math does too, to be honest, but you know what I'm trying to say. All right. Let me see what time we got. Okay, a little bit more. I know today's there's a lot happening today. I know. Here's the thing about, just to cut to the chase on addition, subtraction. Real quick. Don't look at this. If I ask you to add this by hand, if you had to add this thing over here by hand, how would you do it? What would you have to be careful about? Well, let me add another number in there. Yeah.
You have to align the decimals.
So the important thing with addition, subtraction is the decimal place, right? So when you're adding, subtracting, the part that has the least decimal places tells me what my answer should be rounded to. So see how the first one has 1 decimal place and this guy's got 3? That tells me my answer needs to be rounded to 1 decimal place to match up with the weakest dude. That's how adding and subtracting works. So if I were going to add these two, how many sig figs should my answer have? I'm sorry, how many decimal places should my answer have? Which one? Oh, I'm sorry. You guys are like, I'm not even looking at you guys. 2. Okay. I like it. Because this guy has 2 places, because this guy has 3 places. He's the weaker one. So if you throw this in your calculator, you just have to round it to 2 decimal places. I know this is really weird and really different. I really hope some of you guys understand why science needs this to happen. And of course, that's what this class is math in more of its forms. So math is not just algebra. Math is so much more. Okay. Yeah, Jeff, whatever. Let me see. What else did I? Is there a lot left to do? There's not like a ton left. That's right. This is 3C. Okay. I don't mind. We can stop here. I feel like we've done a lot today. What do you guys think? Is anybody upset? Do you feel like I'm not giving you your money's worth if I let you out early? Are you like, you suck? If you do, just, talk to my dean. Tell him how horrible I am. What time is it? Okay. So let me do this. So again, this is up on Canvas. If you want to take a look at this, there's more examples you could try. And the answers, like I said, the answers are way back here. Here's all the answers.
Sir?
Yes.
Would it be possible to have this one right here with your notes on it?
Oh, yeah, let me see. Yes.
Because that's how I'm learning it. That's how we're learning it. So that's how it stays in my head.
Yeah, it's on the video too, but I could upload this. Let me see. Some notes.
That way, I'm going to print it out. I'll print this one out because it'll be familiar.
All right. So I can do that. You guys don't need to see all that. Let's see. Oh, okay. I thought I missed some stuff in chat, but no. All right. So anybody have any questions about the quiz? I think I need to, it's not quite open yet, which is good because I'm not ready for it to be accessible yet. Let me see here. Some stuff I did this morning did not get in there, so that's exciting. So the way it works, you don't have to print the quiz out. You can print it out if you want to. All right, let me see if I can make these instructions a little bit better. All right, here we go. All right, so let me show you this. Oh, crap. So much. Oh my God. I got like 8,000 windows of okay, hold on. I feel like my grandma. All right, here we go. So once you click on take the quiz, you'll have an hour to complete the quiz. You don't need to print the quiz out. Please do the work on another sheet of paper. You can do the work on the printed out quiz if you like, right? You guys all with me? Got to try to answer all the questions I can ahead of time. When you're done,
I like to print it out.
When you're done, click on the text box below the quiz and type in the time you finished. Then you hit the submit quiz button. I know. It's just the way it has to work in Canvas. Then you scan your work and you submit it where it says submit quiz 2 here, just like we did with quiz 1, right? There's a place to go get quiz 2, and then there's a place to submit quiz 2. I think I still have to create that, but I have a couple minutes here. It's gonna be accessible, where did I say? At 11:45. You can start it right at 11:45 if you want to, get it done. Just make sure to give yourself an hour when you start it, and you have until 7 a.m. tomorrow. So then I have that time to finish grading in case somebody turns it in at the time. Okay. Let me see. I think I got everything. You guys are seeing all about behind the scenes. Let's see. Stop that. Yeah. You want me to show you the questions too? No, I'm not going to. All right. All right. If you have a question, let me know. Otherwise, you are free to roam within reason. And I'll see you tomorrow. Anybody have any questions?
See you. Bye. See you tomorrow.
Okay. I'm out. I'll see you guys.
Bye.
Bye, everybody.
Bye-bye.